Marco, if you are saying, okay, there you go. You're gonna have to turn your
Okay,
mic back on.
there we
That
go.
happens.
Yeah. No, I was just telling to Vanessa that Andrew was telling me that you feel that the project is a little bit slow at this time because of the data processing, which is requiring more than expected,
Right.
because
Yeah.
As
you have to
always.
make sure that
Yeah.
yeah. You have to make sure that everything is correct before proceeding because
Right.
garbage in, garbage out. So if the
Right.
data
Right.
is
Yeah.
crappy, your analysis will be crappy. But at this time, I think it's correct what Andre was saying. At this point, we have input data. We are making sure that uh, our data is clean. Okay, there are some aspects that we will not be able to clean, but we can make some assumptions and we can declare some limitations in the paper. So I don't see it as a huge problem, but we have to do all that's possible to clean the data at the best of our possibility. So let's say this.
Yes, perfect. So guys, if you don't mind, to start our meeting with listen to the file I've just sent in the WeChat. Oh, I'm sorry, WeChat in the chat. And I also pointed out the timeline, from 126 seconds to 128. So it's like 2 minutes and 6 seconds, right? And just to make sure, if it's the one bird singing or two birds. And the question is, because in our file, we have the probability within this timeline. So at this timeline, we have two birds. So one is the, let's say, probability 0.9, and another one is 0.6. So, and we had an assumption with Vanessa that that's the multi-probability we were talking about.
Mhm.
But actually, after listening to the file, I'm not sure about it. So, and I
Okay.
also sent those files to our domain expert, Pranov, to also check it out. So I sent him two files. So, and in this case, if we have two birds, that's one approach of clean data. If we have one bird, that's another approach. So I can share but I don't know if the sounds will be okay, or everyone can download it and try to listen to the file. So just out of the curiosity.
If I access the file, it needs permissions. I've asked for permissions, but maybe if you can share the screen and we can hear the audio.
Okay, perfect. Because Vanessa has it, definitely. One second.
Yeah. Do you want me to? Oh,
No,
just a second.
then we'll do like that. Okay.
Okay.
So, okay. So that's the file, right? So that's the processed file. So, and basically, actually, you see, that's the file saying from this period of time, we have two birds, right?
Yes.
So and the probability is 0.76, 0.6, then right here, and right here. And actually, the Python code I wrote from the BirdNet, it's the same.
Mm-hmm.
It's the same with the BirdNet app outcome. It is totally the same. So they also given us these probabilities. Okay, so now we go to this file. Actually, I'm here. So let's see, 126. It's 2 minutes. Okay, so it's starting 2 minutes 2 seconds to 2 minutes 9 seconds. Okay, let's do that. Okay, 1 second. Okay.
Oh, you probably didn't share the audio
Okay,
when sharing your screen.
gotcha. Let me see. How can I do that?
Try to turn off the sharing and
Spatial audio, maybe more audio things.
no,
Okay.
I think you have to stop sharing and sharing again. There's a tick that you have to
Okay.
turn on.
Add background. Okay. Excel. Okay. 1 second.
Include sound or something similar.
Oh yes, right. Oh, perfect. Yes, I'm sure. Yes. Okay. Sure. Yes, perfect. Yes. Yeah, I just toggled it. Okay. So starting from 2.6. Okay, let's put it. So 2.6 to 2.9. Is it one bird or two birds? Probably two birds.
Yeah, I
Could
kind
be
of feel
it could be
like
3
it's
birds.
two.
Yeah.
Yeah.
Right.
So, yeah, we can just jump like to like two more chunks. Let's see, like 138. So it's like what? 218 to 221. Okay. Okay, that's 218 to 2. Definitely more than one, right?
Yeah, it sounds like there's two birds here. Yeah.
Right.
Yes.
Which I think makes sense, right? Because if
Yeah.
because this is just the data coming from BirdNet, the application, and the way it processes things is it takes like a spectrogram and it basically sees like the spikes, right? And I'm just speaking high level, and from what I've seen using the app myself, like out in the wild, and like what it'll do, it'll show you an actual. Maybe I can show you guys. This isn't BirdNet, but it's like the same thing.
Yep.
But what it'll do, it'll start recording, and then all these little spikes or whatever. So I almost wonder if, and then once you pause it, it'll analyze it and tell you what birds. But I almost wonder if there are two different frequencies going on in that 3-second clip, and then that's why they got two birds.
Yep.
Yeah.
When we put this through your code, Andre, like the probability code to discern, did it have multiple probabilities for both birds that we
Yes.
saw?
It's the
Okay.
same.
So
It's the same.
okay,
Absolutely.
it's
So like
interesting.
1 second. Let me just find it out. 1 second. It's really funny. Okay.
This is
Okay,
in
got it.
2.4.
So that was okay. So yeah, let me just show you again. So that's okay. So that's the file coming from the Python code, right? So basically, I mean, it's a little bit different, but same idea. So, and this is from, okay, 1 second. Okay. Oops, I'm sorry. Yes, so you see that we have the same right here. So like 129. So okay, 1 second. Let me do. Okay, anyway. So like it's the same. Like the Python code and the BirdNet code. So like it's giving the same outcome, basically. But in my case, like if we were running like confidence level like 0.1, just like out of the curiosity, it can give you like 4 probabilities. So it can catch in like more birds. But in our case, it's not relevant because 0.1 is not the what we're looking for, and 0.5 it is a cutoff for the probability for defining the class. So
Right.
in this case, probably we are not talking about multi-probabilities. We are talking about catching different birds. So in this case,
But
the approach.
actually, in our case, aren't we interested in just retrieving the samples where the Hume leaf warbler is singing? So if there are two different birds overlapping, I think it's okay, but we need to keep the sample if and only if there's also the Hume leaf warbler, no?
That's the second stage of the research project, because the first stage it was like just okay guys, you have to investigate what is going on around. and just tell us
Yeah.
like, okay, any insights, like, okay, like as you mentioned in your feedback, okay, guys, I want to see like what's going on like during the day, like let's say like in the morning, who's like more active, like let's say in the afternoon, who's more active, and who's thinking around the Hume's Warbler. That's the
Mhm.
first. And when we go to the second part, like machine learning, yes, we don't care about them at all. Just they just like another class, not the Hume's Warbler's class. Yeah, but in the first part, mm, I'm just yeah, I'm just a little bit um not
And
lost, but it takes a little bit
and
longer.
a lot of times, when we see two birds in one sample, it'll show our one of the birds won't even be in our expected list. So where do we go from there? Do we just throw out that data point altogether? Do we, um, like, I think the one that you showed, what was it? You said 126 to 129.
129, yes. And
Um,
I pointed it in our chat.
right. Were both of those on our expected list? Like
I
Pranav list? Do we
I
know?
didn't check this out yet. The point is, some of them will be in the list, some not, definitely. And actually,
Right.
at this point, I also wanted to discuss the accuracy approach Annan proposed us, because we also might use another approach as well. Because I mean, I love the like lower boundary and the higher boundary of the accuracy, but we also can assume, let's say, the BirdNet model, it is a quite well calibrated. So, and let's say zero point 0.5 means that let's say like in this way. So we can calculate the accuracy by the mean average. Let's say if you go like by 0.5 and above, so we just calculate the mean average of the whole data set, and it will be around like 0.7, like point like 65, because like it goes like 0.5 and up. So in this case, it can mean that the accuracy of all data set, including right classes like class 1 could be like 0.7, and class 0 could be also like 0.7. And when we are going up, let's say to the 0.95 confidence level, then the accuracy, assuming the model is well calibrated, will be around like 0.96, 97, a little bit higher than the confidence level. So we can assume that model is predicting the both classes with the accuracy, with the mean average of the data set. That would be like also another approach. It's a little bit different, but also the assumption of the accuracy of the data set. What do you think, Marco? But we're not
Yeah,
sure
I
about
think
if it's calibrated well.
yeah, I think it sounds like a good idea, but we need to assess it. So if we have two different approaches, I think it makes sense to try them both and see what happens on our data.
Okay.
But at this stage, I think it's very important to take everything you've done and everything, all the assumptions we are making, and write them on paper.
On paper, yes,
So that
absolutely,
we
absolutely,
can,
yes.
at this point, we have to, at least the four of us, me, you two, and Annan, have to agree on them so that we can proceed. And also, if we need some feedback from the domain experts, we can ask them. So I was wondering, have you ever used Overleaf LaTeX?
Yeah, I've used it before.
Yes.
Yes. Okay,
Mhm.
perfect. And with your university, do you have the possibility to create a project and share it with us? Usually, the free accounts can share to at most one other person. If you
Yeah, I
can't
think
do that,
we have a university account. Can we not share it with other
okay.
universities? I think Georgia Tech, I've used it through Georgia Tech before.
No, yeah,
Uh,
you usually you need a subscription to share it with more than one other account. But if you have universities often have this subscription, so often you can share to multiple accounts.
Okay, yeah,
but
we can do that.
If so, you can start creating an overleaf, a simple template without, I mean, the standard one. It's okay. And let's try to write a data processing section. Okay.
Yes.
Where you specify your input data, your objectives, and what you are doing. So if there are some limitations and so on, you have to write them. And this section has to be very specific and formal, you know. So how many data do you have as input? How many data are you filtering out? And so on and so forth.
Okay, perfect. Yeah, sounds very, very reasonable.
Yeah, and then we need also to the first part of the project is exploring the data we have. So we need to define some hypotheses. For example, just the thing you were observing, the fact that in one sample there might be two overlapping birds, might be one thing to explore. So in which parts of the day there's overlapping between species? Can we observe interesting patterns in the data?
Absolutely. Yeah, I got it. So, and also, like one question, I guess, that is bothering both of us, I mean, me and Vanessa, what are we going to do with species that are not in the list?
I think we can ignore them. I mean, it's an assumption that we're making because our domain experts told us that in the area there should not be this list of species. So assuming this, we are filtering out data about these species, assuming that MerdNet can make errors and can bring these species up when predicting.
Yes. The following up question is, let's say, I only explored two audio files, right? And it looked like one bird is very close to the mic, and another bird is like quite far. So that probably the furthest bird, it is identified with lower confidence level, probably. Because like all the noisy sound around, or like the frequency can be not that clear, like the capturing sounds can be not that clear. So we know, let's say like by empirical experience, right? Experiment. I'm sorry, experiment. That we have two birds, and one is identified not well because it's not in the list, but it exists. So it gotta be in the list. Definitely, right? So,
yeah, I mean, guys, you are working with I think a very difficult scenario because all your data is from the real world. So the real world can be very noisy. And yeah, the distance from the mic can be a factor, but we have to acknowledge all these factors and write them on paper because a reviewer will understand that the real world is complex and that we are making assumptions. Our aim is to make good assumptions. So if we ignore some aspects, there's a famous quote that says that all models are wrong, some are useful. Okay, so our assumptions will impact our analysis. Our aim is to make them have a low impact. And for some of the assumptions that we make, for some of the limitations, we need the opinion of the domain experts. Others can be done without them, but let's list them all on the file. You can write a limitations section where you list all these limitations.
Okay, sounds perfect. I mean, yeah.
Some of the assumptions that we've made so far, just so it's clear for me also. One is I guess species that are not expected, we're removing that data altogether because we've been told by the field experts that they're not going to be there. Another one would be, so if we do have multiple birds in one sample, if one of them is unlikely or one of them is unexpected, then we remove them. And then are we also going to bring confidence level into our assumptions? Like assuming, like, are we using some sort of assumption to dictate what confidence level we're going to be doing later processing with? Or
Yeah, for example, for the confidence level, I assume that at a certain point, we will use a specific confidence level to proceed.
okay,
But before doing that, we need to do some preliminary study to understand which confidence level is optimal for our objectives.
right,
Okay.
right.
Okay.
Perfect.
And so also for the species that we are ignoring, on the paper, we need to write them all together in the section so that
Mhm.
the reviewer or anyone that knows BirdNet can understand that we are considering just some outputs. And also the overlapping sounds, probably based on the analysis that we want to make, we will decide whether to consider both the sounds or consider the prevailing one, because probably you have two sounds and one that comes with a higher confidence scores. But for example, if you are studying all the species uh, uh, independently, then you can consider both the sounds. No?
Mhm.
But
Right.
yeah,
Okay.
in my opinion, we need to write the data processing pipeline we are following, the limitations,
Okay.
and a very long list of hypotheses that we would like to explore. So that having, I don't know, 20 hypotheses related to overlapping sounds, the presence during the day, the trends that we can observe, and so on, we can give these hypotheses to the domain experts, and they can point out which of these hypotheses make sense and which of these do not make sense.
Absolutely. Okay. Okay. Sounds good. Uh,
And is this something that, like the hypotheses that we come up with, are they specifically looking at the data as data, or like are we looking for ecological patterns? Like, I know that's not our expertise, we're more like this, the computer science people, but are we like trying to make assumptions or hypotheses based off of the trends that we're seeing? Or is that something that we should kind of give our information to the domain experts and they kind of come up with, oh, well, this is something that would make sense? Or are we just going to look strictly at the data and try and come up with something?
Yeah, I think there should be some uh, dialogue between the two parts,
Okay.
because, for example, we can assume that some specific parts of the day contain more birds. And so what
Right.
we can do is observing the trends. But then domain experts have to, I mean, we can discuss these trends together and see if we can notice something that makes sense. But domain experts will have a lot more things to, a lot ideas that we don't have about these patterns.
Right.
You know,
Right.
I don't know. I know that we could observe some overlapping sounds in during the morning, for example, because they
Mhm.
wake up at the same time. I don't know, but
yes.
Right. I mean,
probably
they
domain
do, yeah.
expert. Oh yeah, yeah,
Early
Yeah,
birds.
yeah.
Yes.
They're usually more like, yeah, that's where the phrase early bird gets the worm. They're all they're up in the morning. And I can hear them
yeah.
from my window in the morning. I know. Um, okay, that's okay, that makes sense. I mean, I just finished doing the analysis of all the data because now that we have high elevation, and there was some differences. Um, but I think Andre mentioned this earlier. We can also maybe try and collect some hypotheses around Hume specifically and like other birds related to Hume's. Like the other one, I think it's like Western crown warbler or something. It has almost like identical patterns to
Mm.
Hume. So I almost wonder if that's related. Are these two birds, seen together often? Are they related in some way? Like they're behavior or something, right? I don't know if we can, I mean, I can't make that assumption. I don't know enough about that bird, but I almost wonder if that's something that's significant enough that we could make a hypothesis around.
Hmm.
Um,
Yeah, you could
but
study, for example, the correlations between what's your background in statistics, mathematics, and so on, probability?
I don't know, a normal amount.
Okay, but we can do that together. But the idea
Okay.
would be, for example, studying the correlation between one species and the other to get similar species or species that are interacting somehow. Because I think the overlapping thing might be very interesting, no?
Yeah.
Because and also we can define what we mean by overlapping because now having seen your audio, Andrei, I'm thinking about overlapping as the 3 seconds that we have. But if we enlarge the window, maybe we can consider all that happens in 1 minute as something that overlaps. You know,
Yes,
so
actually, yeah, it could be. So we can see the pattern like within like let's say 1 minute or like 30 seconds and see like if we have these like small chunks. Yeah, absolutely.
yeah.
Okay, perfect. A lot to do. Nobody told us the real world is that complex.
Yes.
Okay.
Okay,
Okay,
so
cool. So, sorry, go ahead.
no, next step is simply to write down all the assumptions and
Yep.
finalize the data processing pipeline, whatever the assumptions are. You know, you don't have to look at this process as a waterfall. So
Yeah,
we are
absolutely.
we can change our data processing if we realize we made huge mistakes. Okay, but let's proceed now to the analysis of some hypotheses so that we can show them to the main experts. We can have some feedback and we can proceed to the Hume leaf Warbler analysis at that point.
Sounds good.
It would be very interesting. I don't know if you ever studied graphs and
And mass.
graph
I
analysis.
mean, I know like just like a general idea. Just I mean, but it's a little bit to me. It's like just I have to like study it. But I know like it's quite I know it's quite strong school in Russia and like in like all these countries like about the graphs like in math. So they have like very good base. But I haven't like touched that field of math
No,
yet.
I was wondering because I've studied a lot of different scenarios with graphs because graphs are a real are a good way to model the real world, you know, because they can be used to model everything. If you imagine a social network, you have the user which follows another users, which make likes a post, the post can comment a post, and so on and so forth. So one question might be, and it's not related to what we have to do right now, but one question might be, can we build a social network of these birds?
I love it.
Mm.
I love it. To be honest, I love that concept. Absolutely. Because they live in the same area. I mean, like different elevations, different, like a little bit different areas. And we have the map. We
Yeah.
have the map
Right.
of all the locations. Because, like, I mean, I can show it if needed, but we have the map. And some mics are closer to each other. So, like, there could be some interesting patterns. But for that social networking, if you have any, let's say, uh, material you think it's a good like for beginners, just know to get the main idea, just okay, what are we talking about? You can send us in the feedback, and absolutely that will be awesome because they are interacting. They are absolutely.
Yeah.
They're not that social as we humans are, because like we like very social, but probably they still like delivering some messages to each other like area or like mating or something else, and it is the social
Hmm.
communication, absolutely.
Yeah. Hmm. I, I don't have inputs that are somehow related to birds, but you know, graphs can be. I mean, the important to define a graph, the important thing is defining nodes and edges. So in our case, a node is a bird, probably, or it's very difficult in your case because obviously you have to extract the 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 graph from real world data. So it's very, very difficult. But for example, around a mic, can we consider a list of nodes where each node is a species?
Okay.
And
Mhm.
how can we define the interactions between the birds? So, if you imagine your graph, how can we build the edges between the nodes?
So what is the difference between let's say a node and an age? What is like just let's say
If you think,
just give the example on human
yeah,
society.
if you think about a social network, uh, uh, when you are posting something on Instagram, okay, you are a node. So the user Andrei
Oh,
is a node. Okay, the post is another node. The fact your action, so you that are posting a message, is the interaction between you and the post.
okay, okay.
Okay, when you follow Vanessa, the follow action is the interaction. So you have two nodes, Andre and Vanessa, and the edge between the two nodes, which would be the interaction.
Okay. Interesting. Interesting. I mean, it sounds like something very uh not fantastic, but very, very amazing and insane if we can get so many patterns. Definitely. I mean,
Yeah, you can
I
start to think about it in the back of your mind,
yeah,
yeah. Yes, not right now, absolutely.
because it's interesting because we don't necessarily know if they are communicating with one another. They may just be communicating amongst themselves in the same
Yep.
Yeah,
space.
Yep.
yeah,
And the same way that we're creating a node is like the way we would be creating an edge almost because we're just using the sounds. You know what I
yeah,
mean? So it's hard to know if they are connected, if that edge is connecting two nodes or if they're connecting. Yeah. But I almost wonder if it's worth, and I'm going to look into this, like just looking at, um, and maybe widening that window and eliminating multiple data points that are the same bird. That would be an assumption. Like that, if we hear the same bird in like a 6 or 15 second clip, if that's one bird, and to see if there are what are the and we talked about this earlier, like what the surrounding birds are in that
yeah,
window.
Yep.
Um, just to see, yeah, like the relationships with the other birds in the area because there are a lot of birds, different birds. Like there's a
yeah.
whole, and I only picked I think the top 30 to look at when I generated the plots and stuff, but um yeah, I think that would be interesting to look at, just like
And
the
also the buds versus cool thing that we were thinking about at the beginning and that will be
yeah,
used in the future. This type of sounds are a way for birds to interact.
right, right,
So
right.
these actions might be used to define the edges.
Mhm.
Yeah, absolutely. Because buzz is basically the communication within the same species, like for mating. Like just I want to mate with you, so I'm just like saying. But the song, I guess, is like it has wider like communication range. So you just talking to anyone within your area. Probably. I mean, that's what we heard from Pranav and Benjamin, our
Yeah,
Right,
domain
right.
experts.
Yeah, like
Yeah.
we don't I think that's what's one of the things we're trying to figure out is if the buzz is indicative of breeding because only the males I think buzz
Yes.
and sing. And
mhm,
so they're trying to figure out if, and I think, well, I guess no, the audio lots are not near the nest. That's just the cameras. But um yeah, and I think, and for that, would we want to just, and this is just me developing hypothesis for like our next step, would we want to just collect the Humes, so take out all the other ones, all the other birds, and just look at the Humes data and try and see if there are patterns there, or do we want to
Yeah, I think
continue
you
to
can
use
see.
other?
I think you can see it as with a top-down approach. So at the beginning, you look at all the data, then you isolate the one you are most interested in, building some
Okay.
hypothesis on this type of bird. But actually,
Okay.
I wanted to give you also another input on the graph thing, because you have to consider graphs as a way to model the data. Okay, so in what I was saying before, I meant nodes as representative of birds, but maybe what we could do is using nodes to represent places, locations. So just as an example, a node might be the mic. In one of my first research work as a master science student, it was during COVID, so the pandemic. So what we did was representing all the regions in Italy as nodes, and we had some mobility data across the cities. So our aim was to understand if the mobility across the regions was kind of correlated to the infections.
Okay.
So we had a place represented with nodes, but
Nodes, right.
each place had an attribute, more attributes actually. One related to the infections in this place at a given timestamp. Other attributes might be related to how many people there's in this place at this timestamp, and so on and so forth. So that they're called graph convolutional neural network. Simply, it's like the CNNs but made for graphs.
Okay.
We studied these patterns,
Interesting.
So,
I
for
think.
example, you can
Sorry, go ahead.
study, you can try to understand if there's some moving of some birds from one place to another in this way.
And actually, I
Okay.
just sent the map to our chat. But I mean, I don't know. For the audio and video spots.
I have to request access for everything here.
Oh my gosh. Okay. Yeah. So
Maybe Andre, you want to share your screen and show it? Because I think this is pretty interesting.
yeah. Let me see. Oops. Sure. Oops. Oh my gosh. Okay. Oh, the video. Okay. So yeah. So that's the red. That's the nest locations where the video cameras are set up, and the blue is outermost locations, and we see like the elevation right here, like the elevation, and this is the longitude and the latitude. So we can see like PSL, it means like low level. PSM, it means medium, and let's say H is high. So and it shows like it's more red, like even like more burgundy. So like this is like more pinkish, that's low. So that's the locations of the both cameras and mics. And even like some of them, as you can see, like are very, very close to each other. Like I mean, and just to give you the idea, probably this is the it will be within like maybe like 50 meters, like okay, like 150 feet. That's the distance between them. Yeah, just like the idea like how close they are. Yeah, so that's
Interesting.
the Yeah, so that's what we have. Like you see, like right here, I guess it will be like the distance, maybe like 20 meters, maybe 10, like right here, because like it's almost overlapping.
Yeah, 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 yeah. And here, for example, if I had to define a graph, probably I would define, I don't know, maybe um, two types of nodes where the mics and the nest might be types of nodes, but
Absolutely, actually,
the
definitely.
the nests might be related just to a subset of the mics.
Yes, and just one remark on the nest location. So that's the nest of the Hume's Wolbers only. So on the red, I'm sorry, yeah,
Yeah.
so I was a little bit I was saying wrong. So the red is like for the nest, and you see like here we have two nests very close, and those nests are Hume's Wolbers nest and the
Mm,
mic right here. And like
okay.
every nest has the camera. So we have two cameras and one mic in this location. Or
Yeah.
like two nests and one mic here. And some mics just like some like in the middle of nowhere. You see like where are the nests, and like it can be like around let's say like 500 meters. That's the approximate distance. And
Yeah,
so like
I think you guys you have to brainstorm a lot about the hypothesis you wanna make because, for example, one hypothesis might be related to okay, we have some nests that are Hume Warbler's nests, but can we listen Hume Warbler sounds in very, I mean, in which other nests, in which other mics we are detecting these sounds? And to which extent. So if we hear this sound from a very, I mean, a mic which is 2 kilometers far away from the nest, it might be of some interest for domain experts. Especially, it might happen in specific parts of the day, you know. So maybe we don't know why, but
yep,
domain experts will.
absolutely. Yeah. Yeah, but it's just you have to know like how to clean the data, like the basic data. That's it. And then yeah, but we gotta write down the paper and see like what are the assumptions and see how we approach. That's it. It's probably
Yeah,
that's the best way.
yeah, 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 yeah.
Because you don't want to make the wrong conclusions if the data set is cleaned in inappropriate way. Just because we have the conclusions, but they can be wrong.
Yeah, 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 yeah.
That's why
I
we stuck.
totally
That's
agree
why we
with you.
stuck,
Yeah,
Vanessa. Because we meeting like twice a week, sometimes once, and we basically like talking. Okay, are we doing well on cleaning the data? What will be the approach? And that's I will say the main obstacle. And at the same time, that's what we have to work hard on it. Because
yeah.
yeah,
But at the same time, uh, don't feel stuck because you know if you are making something wrong, it's okay to be wrong. Okay, so we can make errors now and realize them after the analysis and adjust the data
okay,
processing. Okay, but at this point, we can make errors. The important is making sure that the assumptions that we're making seem to be reasonable. Okay,
okay, perfect.
because also if we are gonna make mistakes, fortunately we have some domain experts that will look at our analysis and can flag something that's kind of wrong. I mean, as a machine learning specialist, for example, I know that if you give me as a machine learning models with 99% of accuracy, there's something wrong. So
Absolutely.
there should be something similar for domain experts, you know.
Yep, yep, yep. Okay.
Okay.
Now that we have multiple probabilities for each data point, or I guess they don't always have multiple probabilities, but like what does that say? Or and what was the point of all that basically is my question. Like having multiple probabilities from BirdNet for each data point. Like what does that tell us? Does that help us discern between multiple birds being detected in one data point? Is that what it is, or is there a bigger
Basically,
math
it'll.
thing that we're trying to solve?
I think it allows you to study the thresholds. So,
Okay.
if the probability of the Hume leaf warbler is more than 0.1, you can study it, and you can set different thresholds to understand how the threshold impacts your performance.
Okay. Okay, cool.
Okay.
Okay. Good job.
Thank you
And
so
yeah,
much.
let's proceed. And I'm waiting. I'm looking forward to your document. You can
Thank
share
you.
it with us now or when you feel it's ready. It's not a problem
Okay.
for us.
Absolutely. And
Yeah, I
if you
might
don't
just
mind, go. I'm sorry, Vanessa, go
no, no,
ahead.
you're fine. I might just go ahead and make a template and
Yeah,
then and share it so everyone can see.
sounds good.
Perfect. Yeah, if you don't mind, like just sending like some, general idea about the graphs, like social network. Yeah,
Yeah,
just
yeah.
just like some simple like beginner level, like dummies level, to make the let's say to get the idea what it's about. And it sounds very, very cool to me, to be honest.
Hmm. Yeah, actually, I think there was a tutorial on GCNs, so the graph convolutional neural networks, that is kind of simple and effective. I'll search for it and send it to you.
Okay, cool. Thank you.
Perfect. Thank you so much,
Great.
guys.
See you not next week, in 2 weeks.
Week after. Mhm.
Yep.
But write on the Teams or whatever if you have doubts and questions.
Absolutely.
Okay.
Will do.
Okay.
Thanks,
Thank
Marco.
you.
Bye bye.
Thanks, Andre.
Thank you. Bye bye. Bye, Vanessa.